Now, we also talk about states and properties of matter. We all should know this because we are very familiar with it. We've experienced it in our everyday life that matter on Earth exists in these three physical states. There's a fourth, but we're not going to talk about that. These are very common. We have experienced, like I said, we've experienced it in everyday life. We have the solid phase, we have the liquid phase, and the gas phase. And different matter can undergo changes from a solid to a liquid, from a liquid to a gas, and back from gas to liquid, liquid to solid, depending on the temperature. Whether a compound then, whether we can find it as a liquid, solid, or gas, it will depend on these two things. The distance between the molecules that make up that particular compound and the speed of the molecules, or in other terms, their kinetic energy, how fast the molecules are moving. In a solid, the distance between molecules is very small. As we move from solid to liquid to gas, the distance increases. The same is true for the speed of the molecules or their kinetic energy. In a solid, the molecules are very close together, very tightly packed. They don't have much room to move. As we move from solid to liquid to gas, the molecules in a gas are really far apart and they have a lot of kinetic energy. They move very fast. And therefore, their kinetic energy increases as we're going from a solid to a liquid to a gas. If we increase the kinetic energy, we also increase the speed of the molecules. This is our review, really, because we all know these characteristics. A solid has a definite shape and a definite volume. The particles in a solid are very close together and they're held by a very strong attractive force. It could be a covalent force, it could be an ionic force, and we'll talk about those types of forces later, but they're held very closely together by these attractive forces. And they're arranged in a rigid pattern. As you can see here, there's a pattern. And we can see them as crystals, for example. Once the particles are in this rigid pattern, they cannot move around. As you can see, they're very tightly packed, and so they cannot move very easily. They only vibrate a little bit in the fixed position. So if I have this silicon over here, it's already bound to oxygen on either side, and it cannot really move much because it will run into this oxygen or that oxygen. And therefore, it can only just vibrate a little bit about that particular position it has. This is true for all of these atoms. And therefore, the solid is very dense. In general, solids have high densities, and they are crystalline in form because these particles are very close together and they're arranged in a particular pattern to form a crystal. Liquids, they have a definite volume, but they don't have a definite shape. They are poured. They take the shape of the container they're in. This is a characteristic of a liquid that changes from a solid. They take the same shape as the container, whereas the solids do not. They have particles that move slowly in random directions. So these particles now are not as tightly arranged in a pattern as the solids. They're not rigid anymore, but they're in close proximity, not as close as a liquid, but they're close enough to feel the attraction or the interaction of the other molecules around them. Therefore, they move a little better, but they're not independent of the other molecules in that liquid. So they have a higher kinetic energy than the molecules in the solid shape or solid phase do, but they do not move as freely as the molecules in the gas phase. So if we think of liquids as the in-between phase, that would be correct. Gases, therefore, have an indefinite shape and indefinite volume. So it's not a defined shape or volume. They can take the shape and volume of any container that you put them in. It doesn't matter. That is, so in the gases, the molecules are really, really far apart and they move at high speeds, which means from a couple of slides ago that they have very high kinetic energy. And because they have high kinetic energies, they don't feel attraction to other molecules. They're not, because they're not very close to them, and they move at very high speeds, and therefore they, even if they were to interact with another molecule, they would interact so briefly because they're both moving so quickly that they would run past each other, so they wouldn't really have time to interact very much. And that's why gases have such a shape and volume that will fill any container. That's because their molecules are so far apart and they move at very high speeds, so they do not get attracted to other molecules in the gaseous phase per se.